Now question number 81. Volume of 0.2 molar acidified Cr2O72 negative solution required to oxidize 50 ml 0.3 molar C2O42 negative solution. It means in this case we have dichromate solution which is oxidizing oxalate ions, and there would be Cr3 positive that's formed here and CO2. So let's check the oxidation states of the species. If I talk about chromium, here it is in +6 oxidation state. Carbon is here in +3 oxidation state. Here this is chromium, this is in 3+ oxidation state. And if I talk about carbon in CO2, that is +4 oxidation state. We know that N factor for any species we can find out with the help of change in oxidation state per atom. So +6 is here, +3 is here, Cr2. So the N factor becomes 6 for this case. And for carbon, there are 2 atoms of the carbon, oxidation number is +3 for carbon, and here carbon has +4 oxidation state. So per atom the change in oxidation state is +2 for this case. Now what we are going to do, we are just going to oxidize oxalate ion with the help of dichromate ions. So in this case, the equation N1V1, normality equation, N1V1 is equals to N2V2 should be satisfied. And this N1V1 can be represented as N factor molarity, because concentration is given in terms of molarity. That's why I did that. Further, is equal to N2, M2 and V2. Now, N factor for dichromate ion that's given here for chromium, it is 6. What is its molarity? If I talk about the molarity of Cr2O72 negative solution, potassium dichromate solution we are taking here, that is 0.2. What's the volume here that we need to find out? So I'm just taking here V1. That is equal to N factor for the next solution, the solution of oxalate ions it is. Molarity is 0.3. and the volume is 0.50 ml it is. Now let's solve this for the value of V1. It becomes 2 into 0.3 into 50 and it's divided by 6 into 0.2. So we can represent it as this. So this could be cut here and 3 2s are 6. It is 25 ml. The volume that would be required. Where this 25 ml is given, this is correctly given in option 3. That's why answer for this question becomes option 3. Let's take next question. Question number 82. If mole fraction of solvent in aqueous H2SO4 solution is 0.85, then the number of moles of solute present in 2 kg of solvent is. In this case, what you have the mole fraction of solvent, that's water. So Chi H2O is 0.85. What about the Chi for H2SO4? That is equal to 1 minus 0.85, that is 0.15, you know that. And one more thing. Mole fraction of H2SO4 should be equal to moles of H2SO4 divided by the total number of moles of the solution. So in this case, let's assume that the moles of H2SO4 that I'm writing here, NH2SO4, moles of H2SO4, these I'm assuming X. So it would be equal to X upon H plus moles of water. So NH2O I can write here. Now moles of water we can find out with the help of the given amount of solvent, that is water basically. So NH2O we can calculate by dividing 2000 by 18. And if you divide that 2000 by 18, so this value becomes 2 into 55.56. These are the moles of 56. So these are the number of moles of water. I'll just place here the value. Chi for H2SO4, that is 0.15 is equals to X upon X plus 2 into 55.56. So this value I can place here, or it can be simplified as 0.15x plus 2 into 55.56, that value is equal to x. Now it's your turn. Just solve this for the value of x. So simply we can write here. So simply on solving you can get x value that is equal to 19.6. These are the mole of H2SO4. We already assumed about that. Now if it is so, we can easily choose option 4. That becomes the correct answer for this question. Let's take next question. Number of electrons having L plus M is 0 in potassium atom is. First of all, we need to just write here the electronic configuration for potassium. What is its atomic number? That's 19. And its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1. This is electronic configuration. We are talking about M plus L value that is 0 in potassium atom. Let's represent these electrons in orbitals. This way we can represent them. Six electrons are here. All are paired. Further. Again 3p orbital. Now if I talk about s orbital, for the s orbital L value is 0, and if L value is 0, M value is minus L2 plus L, it will also be 0. Further, for the second case, L is 0, M is also 0. Here also, L is 0, M is also 0. L is 0, M is also 0. Now, if I talk about the number of electrons associated with these quantum numbers, double of this, 2 electrons are here, 2 here, 2 here and 1 here. Further, if I talk about this p orbital, in case of p orbital, this L value is 1. Now, M value is from minus L2 plus L, you know that. And on that basis, this value of M, if minus 1 is there, then L plus M would be 0 in this case. It means one orbital is showing M plus L value as 0. Similarly, here also L is 1 and M is minus 1. So what would be the value of L plus M? That is 0. And if it is 0, it means one more orbital is showing that. So total number of orbitals which are showing this case is 1, 2, 3, 4, 5, 6. So total number of electron associated with this M plus L value 0 are 2, one pair, further 4, 5, 6, 7, 8, 9, 10 and 11. So total number of electrons having L plus M is 0 are 11. And that's why option 4 becomes my correct answer. Now after that, question number 84. Subshell with highest energy of electron in hydrogen atom is 5s, 5p, 5d and all have same energy. If I talk about one electron system like hydrogen atom, in that case energy depends on n value, that's principal quantum number, and all of these cases have the same value of n because number of shell is 5, that's why all have same energy, and option 4 is the correct answer for this question. Let's take next question. Now the question number 85, the electronegativity of an atom in Pauling scale which have ionization potential and electron affinity 13 electron volt and 4 electron volt respectively. So first of all, we'll just find out the electronegativity on Mulliken scale, that is equal to the ionization potential and electron affinity, the sum of these two divided by 2. With the help of this, we can find out the electronegativity on Mulliken scale. Let's find it out. IP is ionization potential, that is 13, plus electron affinity is 4 divided by 2. This is 17 by 2. So this can be written as 8.5. Now, electronegativity on Pauling scale is equal to electronegativity on Mulliken scale divided by 2.8. So, 8.5 divided by 2.8 is equal to 3.04. And if this is the value, definitely option 2 is the correct answer that you can easily mark here.